Any question if you guys have? नहीं? तुम इतना जो मुस्कुरा रहे हो we're discussing pressure belts. We understand the idealized pressure belts. Seven pressure belts, right? We can explain it also, all the 7 pressure belts. Now this idealized pressure belts, whatever we have discussed, have 2 components in variation. One is the spatial variation, another one is intra-regional variation. If you look at the spatial variation, this is what you called shifting of pressure belts in response to the changing location of vertical rays of the sun. Intra-regional variation is primarily associated with land-water contrast, the most dominant factor affecting the pressure system, apart from the insolation. So, if it is a question solely on it, or if it is only about variation or changes in the idealized pattern, both has to be talked about, right? Here we'll talk about the pressure cells, the permanency of the primary belts. Here we'll talk about North Atlantic oscillation. Here we'll talk about polar vortices, polar vortex. It has 2 components: the actual pressure belts and the consequence of shift. That is, what are the idealized pressure belts and what are the permanent deviation from that and what are the consequences of it. You can separate it or you can club it in one. The idealized. There is one correction, please. Yesterday, I'm sorry for that. We have talked about the unicellular model as given by Haley. No, that was given by Hedley. And the tricellular model is given by Farrell. Farrell's law. Who has given the Coriolis force? Please correct it. Though we would have in any case have discussed that in atmospheric circulation. So the idealized pattern of pressure belts are rare on the observed pattern. Pressure belts are not only dynamic but also have variation in their global, please, and regional pattern, owing to the factors affecting pressure belts. The permanent pressure belts are rarely permanent. Except that too up to some extent. The subpolar low pressure and equatorial low pressure belt. Subpolar low pressure belt of southern hemisphere only, not northern hemisphere. The most fundamental among the pressure belt is the equatorial low pressure. It changes its location because of changing position of ITCZ, intertropical convergence zone, right, owing to the change in the location of thermal equator. ITCZ is the genuine term used for equatorial low pressure belt, intertropical convergence zone, right? It is more appropriate a term as compared to equatorial low pressure belt because equator is geographically fixed, whereas ITCZ is the zone which shifts, right? So we'll talk about it when we talk about the wind. Thermal equator is the highest value isotherm located on the surface, right? Now, this position, the ITCZ responds to the apparent shift of the sun's position. Consequently, it remains in and around the equator only during equinoxes and move northward and southward during solstices. Owing to the factors affecting pressure belts. Now, equatorial low pressure belt, as we have seen that equatorial low pressure belt is produced because of high temperature, right? And high temperature is associated with the vertical position of the sun and definitely the land water contrast as well. Now, when the vertical position of the sun is at the equator, that is during equinoxes, 2 times. So, at equator, when the vertical position of the sun is there, roughly the thermal equator will lie parallel to the equator. So, equatorial low pressure belt will be created there. Rise of air will be there, and when it moves roughly around 25-30 degree away, the piling up of air and descending in subtropical high pressure belt will be created. During northward solstice or northern hemisphere summer, the ITCZ shift northward, right? So consequently all the pressure belt shifts northward. When ITCZ shifts southward, consequently all the pressure belt shifts southward. That is the general change of shifting of pressure belts, variation in their spatial position. All the pressure belts responds to northward and southward shift of the ITCZ during northern hemisphere summer. The northward shift is far higher reaching up to 25 degree north. Shift of ITCZ यहाँ पे कर लो, that will be clear. And the polar high of North Pole shrinks to cover a very small area. Southward shift is far less because of homogeneous condition in the southern hemisphere. Hopefully we can explain further it also, right? If you understand, just like this, let's say suppose this is the geographical equator in 3 different conditions. Now, geographical equator at southern hemisphere solstice, this is equinoxes, this is northern hemisphere solstice. Now what will happen? At the equinoxes, the pressure belts will be roughly idealized. Equatorial low pressure belt, right? Then we'll have subtropical high pressure belt then we'll have subpolar low pressure belt, then we'll have polar highs, obviously in both the hemisphere, repeating. Subtropical high of southern hemisphere. Now this is the zone of the wind system, right? High pressure belts, the wind will move in both the directions. That's why it is a convergence zone. Trade wind zone. When it is northern hemisphere summer, the ITCZ will shift slightly north, right? Then this will also shift slightly north. The position of ITCZ, the position of subtropical high pressure, the position of subpolar low pressure, and the position of polar highs will be much smaller as compared to that. The position of southern hemisphere subtropical high. It will help you understand the entire consequence as well. When it is southern hemisphere solstice, the ITCZ will shift slightly southward. This subtropical high pressure belt will also shift southward. This will come down. This will also come down, right? And this will be a much larger area.
Northern solstice, the area of the South Pole area will be extended?
Much extended, just like this. It will be reversed there, a counterpart, right? So look at the position. The changing location of ITCZ, the changing location of wind pattern, right? And in this zone where we're talking about, look at here, the ideal subtropical high pressure belt should be here. So this particular area, now the whole area would be experiencing shifting of. Now when the subtropical high pressure belt is here, the trade wind will start from here, right? When the subtropical high pressure belt is here, the westerlies will be moving in this direction, right? So this is the zone which will experience double wind system. नहीं समझ में आया ना? Sure. So two wind system that has several consequences as well, which we'll talk later. So basically this is the fundamental change in the, again we are talking about the idealized pattern only. The way we have discussed about the 7 pressure belts in continuity over the globe, right? So even that idealized pattern would experience variation in their general location, and there will be several meteorological and climatic consequences of it. The pressure belts are again rarely continuous in their elongated extent as well. That is particularly visible in the northern hemisphere. Again, the reason is land-water contrast, very extensive presence of land-water contrast. The subtropical high pressure belt are broken into semi-permanent cells found over the oceans. They are discontinued over the continents, especially during summer, and are present only in the form of dynamic cells over the oceans. Similarly, the subpolar low is also forms semi-permanent dynamic cells over the oceans. Now, these semi-permanent cells in the Atlantic Ocean and Pacific Ocean, each one is formed. Subtropical high, subpolar low. Subtropical high either Azores high or Bermuda high. Summer, winter condition. Subpolar low is only Icelandic low, which gets weakened during winter. Pacific Oceans, we have subtropical high as Pacific high and Hawaiian high. Subpolar low cells as Aleutian low. Again, winter, summer. What will happen here? We can see this. Look at the atlas, it is equator, right? Along the equator, now there will be bending of isotherms, right? Isotherm will bend as per the anomaly of the temperature, right? Now, when we look at the anomalous temperature, during summer season, the continents are expected to have positive anomaly, and oceans are expected to have negative anomaly. Now, what is happening here when the isotherm is moving in the summer season, let's say northern hemisphere summer, it will move along the equator and rise like this over the continents, right? Then again it will move towards the equator and then rise over it and will go all the way like this. This is the most exceptional extension of ITCZ over the North Indian Ocean. That's what creates monsoon, right? So it moves like this and then goes over north of Africa, almost in the southern portion of Sahara Desert, and then passing from Somali, Arabian Desert, and then going from our northern plain, then along the Himalayan region, moves in the Southeast Asia and goes like this. That is the position of ITCZ. Now let's look at the subtropical high pressure belt. ITCZ is somewhat permanent and continuous, right? Subtropical high pressure belt, which is expected to be generated roughly around 30-degree latitude. Now this 30-degree latitude, look at here, is roughly around 15, 23 and a half, 30-degree latitude. This is 30-degree latitude, right? So roughly when we expect the subtropical high pressure belt to be developed during summer month, that will be around 30-35 degree north latitude. Now this belt of northern hemisphere, especially over the continents, will have very high temperature during summer season, and the high temperature on the ground and high pressure contradictory to each other. Hope you understand? So that contradiction will definitely break each other and will fight against each other. A high temperature is expected to generate low pressure. So that's why this idealized high pressure which we expect over the northern hemisphere will be broken and will be missing over the continental areas, which will be generating its own low pressure. That too, that low pressure will not be in accordance with the temperature of that area, because that area is expected to experience subsidence. Right? So there will be conflict between that subsidence and high temperature or low pressure. That's why neither low pressure will be very strong, high pressure will definitely not be developed. Now what happens? They will be found in the form of cells on the oceans. Right? Now that cells have seasonal, that's why we see dynamic. Even the cells are dynamic. When in the summer season, even the coastal temperature of the Atlantic Ocean close to Africa will be on the higher side, right? So that cell shifts westward, close to Caribbean Sea, which is called Bermuda High. Getting that point? नहीं हो रहा है क्या? ज़्यादा तो नहीं हो रहा है? First thing is that the continents will be missing as far as the theoretically what we have read, that air will rise over the equatorial region. They will be cooled down, become heavier, and they'll start moving. That means we can imagine that entire equatorial region is receiving a perfect low pressure area. Then wind is moving from that area. They descend, so a continuous elongated high pressure cell is created. That's the idealized or theoretical perspective of pressure belts. But theoretical presence of pressure belts will not be found for the reasons we are trying to discuss, trying to find out. Why? Because in that particular belt, during the summer season, wherever they are moving or falling or coming under the continents, the high temperature of the continent will not allow the subtropical high pressure belt to grow in that area. Hope is very easy, because primary reason for the pressure belt is temperature, not the rotation or not the dynamism or not the Coriolis force or not the subsidence. So if the temperature on the ground is expected to be higher, then high pressure cells cannot be expected. Right? So they will be missing out from the continental areas. Hope it is clear? Now, they will be found in the oceans, and now this ocean is not a lake. It's a big, huge ocean, and that much huge is this Pacific Ocean. If you understand this, you will easily understand very technical aspect of North Atlantic oscillation or polar vortices. यहाँ पे नहीं समझेंगे तो वहाँ पे दिक्कत होगी, ठीक है? Now, let's say suppose in the middle of the ocean you have cells. Let's say suppose, but this cell is a high pressure cells. So they will prefer low temperature, right? A high pressure cells will prefer to stay in the low temperature area. A low pressure cells will prefer to stay in the high temperature area, right? Now, if you look at this cell, the high pressure cells during summer season, they will shift towards the interior of the ocean rather than preferring to be close to the continents. Because close to the continents, the temperature of the ocean water will be on the higher side. So they'll move towards the interior. That's why they're called Bermuda. This is Bermuda Island. So they're called Bermuda High. When? Summer season. When winter comes, so the coastal areas will have lower temperature than the oceans, so they'll shift towards east. So this eastward and westward shift in response to the change of temperature of the ocean water is that what makes it dynamic cells. Right? So during summer season there will be Bermuda High, during winter season there will be Azores High. Clear? Hai? Now in the same here, Pacific High is closer to the North American continents. Pacific High, Hawaiian High. Right, this is Hawaiian Island. So Hawaiian Island is in the interior of the ocean. Right? The high pressure cells will prefer to be located in the interior of the oceans during which season? Huh? Summer season. Because coastal waters will have higher temperature, right? So they will be slightly discouraging the formation of high pressure cells. So Hawaiian High, summer season, Pacific High, winter season. So that's what oscillates. North Atlantic oscillation. Not exactly the same, but this is what oscillation as well. Now similarly when we see the, hope it's clear, right? Intra-cells variations, the permanency of subtropical high pressure belt will be definitely not there, but in the southern hemisphere relatively land amount is in the southern America and somewhere in Australia. Otherwise it is relatively permanent. So subtropical high pressure belt of southern hemisphere will be much more stronger, continuous and permanent as compared to northern hemisphere. Hemispherical contrast. Suppose if you get a question that discuss the hemispherical contrast in pressure belts. So hemispherical contrast in the equatorial low pressure belt first you'll have to show. And what is that? The shifting of ITCZ southward is very less. The shifting of ITCZ in northward shift is very extensive, covering even 25 degree north in our country. Even Africa is covering almost 15 to 20 degree, but southern hemisphere will hardly be 10 degree. So that is hemispherical variation in pressure belts. First, equatorial low pressure belt. Second, subtropical high pressure belt. Such cells are not here in the southern hemisphere. They are relatively permanent and continuous, which is definitely in the form of cells even during winter season. They are not found continuous over the subtropical high pressure belt because they are, for greater part of summer, they are broken. Now come to the subpolar low pressure belt. Subpolar low pressure belt. Roughly expected latitudinal position is 55 to 60. Now let's come to 55 to 60 roughly around. This is 60 degrees. Okay. That's the whole Siberian region. Right. Continental areas. Right. Why subpolar low pressure belt is permanent? Apart from equatorial low polar, only southern hemisphere subpolar low is permanent. Because extensive oceanic area, no land at all whatsoever. So in this particular belt of subpolar low pressure area, during winter season the temperature of this area will be very, very low. Low temperature and low pressure contradicts each other. Low temperature is not suitable for low pressure. It is favorable for high pressure conditions. So that's why during winter they will be broken, and this area winter is much longer. This area summer is much longer. Right? So what happens here, because of longer winter in the continent area, discouraging the presence of subpolar low pressure belt, they will be again broken and found in the form of cells. Look at here, Aleutian Island, Iceland. So this is developed in the middle of the ocean here as in the form of cells. That is Icelandic low, Aleutian low. comparatively. When we compare ocean with the land, the oceanic areas are supposed to have higher temperature during winter season. So average temperature of that area will be higher. Apart from this, this region is having North Atlantic drift, which is a warm ocean current. Okay? That's why this area remains slightly warmer as compared to you expect. So that becomes the favorable breeding ground for subpolar low pressure cells. Hope you are clear? Now a high pressure cells during winter season, this is the overall variation, their dynamism. Now a low pressure cells during winter season will be slightly smaller, during summer season it will be extensive. So areal extent of subpolar low pressure cells will vary according to seasons. ज़्यादा तो नहीं हो रहा ना? Hope we are clear, right? A low pressure area during winter will be smaller. A high pressure area during summer will be smaller. Remember one thing, the primary reason for the pressure development is temperature. Only the equatorial low pressure and polar high pressures are developed. Then you have the Coriolis force coming into play and then creating subtropical high pressure belt and subpolar low pressure belts. Otherwise they wouldn't have been there.
Can you say in the region of subtropical high pressure belt?
Sorry?
In the region of subtropical high pressure belt.
Yeah, come.
On the continent, there is a distance of small pockets of low pressure.
Yeah, very much. That's how local winds are produced.
And the ocean have small pockets of high pressure.
Not exactly the same way, because the primary pressure belts will defy the local conditions very often. So when we are talking about the high pressure cells, they are part of primary pressure belts. Don't forget that equatorial region is relatively permanent. And since equatorial is permanent, they will be sending air towards that area. Since the surface ground condition is not very favorable, that will be choked and broken. And that's how the deviation and several zigzag wind atmospheric circulation will be the norm rather than the idealized pattern of tricellular model. Even tricellular model is the most idealized expected pattern of atmospheric circulation. Right? So that's when the idealized. The real expected pattern would be slightly different. In fact, very different. So when we say that, that's why during summer season the number of local winds are far higher than during winter season. Warm winds far exceeds the cold winds, local level. So climatic conditions are more favorable for the local winds to generate in that area. That's why Africa has a large number of local winds. Here the consequences of shifting of pressure belts. The most widespread consequences, the two wind system, presence of two wind system, that is trade wind as well as westerlies, in between 30 to 45 degree north and 30 to 40 degree south latitude, producing two unique climatic types, that is Mediterranean and China type along the western and eastern coast of this area respectively. (30 to 45 degree north and 30 to 40 degrees south). Let's come to this itself. We can easily understand what is Mediterranean climate and what is China climate and how it is formed. Let's see, suppose this region is Mediterranean Sea, right? And here you have China. Now what is happening here? What do you mean by two wind system? So subtropical high pressure belt. High pressure belts are the area of origin of wind, though we haven't discussed, but you must be knowing that trade wind is blowing from subtropical high pressure belt towards equatorial low pressure belt. And westerlies will blow from subtropical high pressure belt towards subpolar low pressure belt. So if you assume that this is the zone of subtropical high pressure area, so the south margin or equatorward margin will be sending winds trade and poleward will be westerlies. Now when the subtropical high pressure belt is shifting, during summer it will shift northward, so it relatively occupy the northern portion of Mediterranean Sea. Now the whole region is under the influence of trade wind, right? So trade wind becomes onshore in African areas and becomes offshore in the Mediterranean region, right? That's why the only climate, major climatic type which has summer deficient rainfall, or summer is dry and winter is wet. Onshore wind produces rainfall and offshore winds are dry. The wind which is moving away from the continents will be dry, and wind which is moving towards the continent from the oceans will pick up moisture from the oceans and may produce rainfall. So onshore winds are associated with rainfall, offshore winds are associated with dry conditions. So when the trade wind is there, so obviously trade wind becomes offshore. Here a bit of that marginal part will be onshore. So they may pick up moisture from the Mediterranean Sea and produce rainfall in the coastal area of Africa. Now when it is westerlies, like during winter season, when it shifts southward, the westerlies, this area will be occupied by westerlies. So westerlies will be onshore here as well as here. That's why I say Mediterranean climate, which is a unique type of climate which receives winter high, very high rainfall during winter, and summer is dry. And that produces a very conducive climatic condition for the growth of juicy fruits. Citrus fruits, orchard farming, truck farming, these are the terms used for agriculture in that area. That may be snow or rainfall also. That's why we say precipitation. The term precipitation is more appropriate for that. Right? So this is the condition Mediterranean Sea. So the same region is experiencing two wind. During summer, trade wind. During winter, westerlies. That's why we say two wind system. What happens to China climate? This again, it's not purely because of shifting of pressure belts. Again, the two wind system will be there. But the uniqueness of China climate is that they receives rainfall throughout the year, with dominance during summer season. Right? Rainfall throughout the year means that area must receive onshore winds throughout the year. Onshore and offshore context हम देखेंगे. So if any area is receiving rainfall throughout the year, so that means moisture laden wind must be striking that area throughout the year. That means the wind must be coming from the ocean towards the continent. That means onshore winds. Now what happens here, because the shape of the continent, look at the shape of the continent, when there is shifting of subtropical high pressure belt northward, even the trade wind becomes onshore. Northward shift, let's say suppose this is the high pressure area, so trade wind will be onshore here. When it comes southward, westerlies will also be somewhat onshore because of the shape of the continent. Any shape of the continent like this, if subtropical high pressure belt is here, So any wind which is coming from this direction will be onshore. When westerlies is the subtropical high pressure belt shifts southward, again this is westerly zone and there will be onshore here. So because of the shape of the continent, it makes both trade wind as well as westerlies onshore. Hence receives rainfall throughout the year, but there is summer dominance. Summer dominance because summer trade winds are pure onshore and they are warm. That's why they can pick up more amount of moisture and they bring more moisture. Winter less so. And you can say coincidentally, most of the land parts located in this region have similar shape. Like you see Laurentian area, this area of US, this area of South America, and a bit of Australia also in that particular belt.
Sir, what about India?
India is unique. We don't imitate others. Even the nature have made us so. No, seriously, it's not a joke.
Because of the monsoon thing, right?
No, I haven't come to monsoon.
No, not monsoon, but the shifting of the...
Shifting of the pressured belt is two system. That is trade wind remains trade wind, westerlies remains westerlies. When monsoon is there, when wind is not trade wind. Trade wind is not trade wind is not westerlies. The basic thing about wind, the permanent wind. When we say the permanent wind, trade winds, westerlies and polar easterlies are three permanent winds. Right? They are permanent only because of one reason, that their direction remains permanent throughout the year. Nothing else. So in the case of monsoon, monsoon is a secondary wind, a periodic wind, which changes its direction. Look at here, there is no change of direction of wind. Right? The wind itself is not changing its direction. Rather, that zone is experiencing two different winds. Here, the wind itself is changing its direction. That's called monsoon. So, China climate is different from monsoon. Monsoon is a characteristics of tropical area. Right? And China climate is a characteristics of somewhat subtropical area or temperate region. 30 to 45 degree. Right? Second, affix the general location of pressure belts and origin and destination of permanent winds. Hopefully we can understand. Pressure belts, so obviously pressure belt shifting we are talking about. So if let's say suppose subtropical high pressure belt is here, so trade wind originates from here, and let's say it is the ITCZ. If subtropical high pressure belt shifts here, ITCZ shift here, so both origin and destination of the trade wind is changing. Right? If it is in the southern hemisphere ITCZ and subtropical high pressure belt is here, so destination and origin is changing.
Sir, that particular location is changing.
Location, spatial
Origin
change.
is from subtropical high pressure, right? Origin is like
Origin will always be subtropical high pressure belt, outer margin of. So with the change in the spatial position of subtropical high pressure belt,
location.
so there will be change of origin point and destination of the permanent wind. Sorry, Chandan kuch bol rahe the? Latitude spatial position is changing. Change in the location of origin point. So right now westerlies has started from here. Next time westerlies will start from here. Next time westerlies will start from here. So look at here, not only the origin, but also the destination is changing. Destination point is changing. ठीक है? ये सब पॉइंट कोई भी बुक में नहीं दिया होगा, guaranteed. Now third is change in rainfall pattern. High pressure areas are not supposed to have any rainfall. Only low pressure areas are supposed to have rainfall. नहीं भी जानते हो तो अभी सिर्फ सुन लो, बाद में हम लोग इस पे बहुत डिटेल में बात कर लेंगे रेनफॉल डिस्ट्रीब्यूशन के बारे. So if a high pressure area remains permanently high throughout the year, that will not receive even a single drop of water. So it changes the locational pattern of rainfall along the pressure belts, primarily along the pressure belts. ITCZ is the highest rainfall receiving region on the ground. It changes its location. So कभी बारिश यहाँ बहुत ज़्यादा होगी, कभी उस एरिया में बहुत ज़्यादा होगी, कभी इस एरिया में बहुत ज़्यादा होगी. Right? So that's how increasing the extent, increasing the extent of the effect of pressure belts. Obviously, when rainfall pattern is changing, vegetation pattern will also change. Right? You can add that, thus affecting the vegetation types as well. Vegetation and soil types, both. Fourth point is the most important for us is the origin of the monsoon. Monsoon in brief, अभी छोड़ ही देते हैं इसको बहुत लंबे में पढ़ना पड़ेगा. You can add at that time. Monsoon is periodic wind, and periodic wind is characterized by change in its temporal change in its direction. Right? Sorry? Yeah, temporal change in direction. Then change of location of the atmospheric disturbances, especially cyclones, both tropical and temperate. You would never hear that Orissa and West Bengal has experienced tropical cyclone during December month. कभी सुना है? दिसंबर में उड़ीसा और बंगाल में नहीं आएगा. दिसंबर में चेन्नई में ही आ सकता है बस. नवंबर में, अक्टूबर में या जून जुलाई में. That is the most important period of cyclones in the eastern coast, apart from Tamil Nadu. changing location of the pressure pattern will affect the atmospheric disturbances also. North Atlantic oscillation. Or now, oscillation. Oscillation we hope we understand, and the North Atlantic we definitely understand, right? So the oscillation of what? Here it is somewhat similar to El Nino. El Nino is a change in the ocean current. Here it is change in the pressure system, right? So the variation or oscillation in the pressure gradient force in between the high pressure cells and low pressure cells of North Atlantic Ocean is called now. Now, it is not consistent or uniform over the years, across the years. So, they vary. Azores high, Icelandic low. Right? If the pressure gradient force is very steep, that is called NOO index will be, now index will be positive. It will be high if NAO is index is low, that means it is positive. Low means pressure gradient force is low in between them.
So it depends on the season, right? Summer, winter.
No. Across the years, this year this, next year this, something else. It is generally measured in November to April. Yeah, come.
Sir, you were saying that when it will be higher, when it will be
The pressure gradient force between the high pressure cells this year may be high as compared to last year or may be low as compared to last year. That variation is oscillation.
difference, variation difference.
Pressure gradient force में variation. So pressure gradient force like means the gap between the value of high pressure and low pressure. That's what we have talked about, pressure gradient force. So if the pressure gradient force is very steep or steeper than last year, so that means the steepness of the pressure gradient force is measured, which varies over years.
That's NO.
That's NAO. Right, if example monsoon index. So every year monsoon is not normal, more than that, less than that. So what are the factors? Then you try to assume it. So North Atlantic Ocean is one oscillation which is associated with the pressure variation between the high pressure cells and the low pressure cells. When the pressure gradient force is very steep, that means gap between the high pressure cells and low pressure cells is higher. It is, index is positive. If it is lower, index is negative. Hope we are getting it? Oscillation, hope we understand? Oscillation, deviation from the normal. That's it. Now, when we talk about the effect, you can easily correlate it. Effect of now. A positive index means steep pressure gradient means velocity of wind is high, catchment area is high, so moisture supply will be higher, so rainfall will be higher in the European areas. If it is lower, then rainfall will be lower, affecting other dependent creatures or activities. A positive now will have higher amount of rainfall, winter will be cooler. If the rainfall is high, the temperature will be lower. If the rainfall is low, temperature will be higher. So it's not only about rainfall, it's not only about pressure system, it's about the cascading effect or recurring effect on it. So if the pressure system is intense, the wind will be strong, the moisture supply will be strong, the rainfall will be more, the temperature will be more.
Economy of the area will
Vegetation will be more, obviously. The agriculture and all will be affected positively and negatively depending upon that conditions. Even the stormy weathers will be the negative aspect. If it is very strong, the storms will be more. If it is less, the storms will be less. That is North Atlantic Oscillation. So effect on rainfall, effect on temperature, effect on vegetation, effects on local weather, especially storms, snowstorms and higher amount of snowfall. Polar vortex. What is vortex? Hope we understand low pressure, right? A normal variation or difference between the adjacent area, the value of the pressure system in the adjacent area is low pressure, right? So it will produce normal wind only. Means PGF is normal. Okay? When the intensity of low pressure is increased, that's what you call depression. That means above normal, everything above normal. Right? Then, if the intensity is further increased, we call it vortex. The plural is vortices. That means much above the normal. Wind speed high to very high. Then the peak of it, the zenith of the intensity of low pressure is cyclone. Fourth stage of low pressure is cyclone. First stage is general low pressure, then gets transformed into depression, may get transformed into vortex and may get transformed into cyclone. And even the top of it is tornado. Extreme version of very low intensity. Now, the moment from here to here, intensity of low pressure is increasing, right? So its area keeps on decreasing. For example, a low pressure area may be of thousands of kilometers, right? A depression may be just few thousand kilometers. A vortex will be hardly 1000 to 2000 kilometers. A cyclone will hardly be 500 to 1000 kilometers, and a tornado will hardly be few kilometers. So the aerial extent of that keeps on decreasing. That is vortex. So polar vortex is nothing but a low pressure area. Now polar areas is a permanently high pressure areas due to low temperature, and yet we have polar vortex means low pressure area. That's contradiction, right? I mean, you are talking about a low pressure atmospheric disturbances in a permanently stationed or permanently high pressure areas, permanent high pressure areas, right? How is it possible? Now, basically it is the zone of convergence in the upper air of troposphere over the poles, both poles, which might extend into a stratosphere as well. It is generally of 1000 kilometers in diameter and very often gets broken into two cells. Once they move out of the polar areas, they make winters disastrous, especially in North America and Siberia. Now, just imagine one thing. The polar high pressure is on the ground. What is happening higher up in the atmosphere? Convergence. Ground में polar high pressure because of low temperature. High pressure is area of subsidence, and subsidence somewhere in there will be convergence. Unless until convergence is there, subsidence will not be there. So that converging area where actually the convergence is there, because of very high Coriolis force, creates vorticity, creates whirlpool situation and circulation, circular motion. So that is called vortex. When we see on the ground, so the convergence in the upper area, they create in the middle somehow the circular motion or whirlpool motion. Vortex is, remember, a low pressure area, right? So they are supplying it. So whenever there is extension of high pressure cells on the ground, there will be extension of vortex also, right? And that vortex very often come into the direction and collides with the jet streams. वो हम बाद में पढ़ लेंगे थोड़ा सा. Simply ये जान लीजिए कि polar vortex क्या है. Polar vortex is a low pressure area, a low pressure cyclonic conditions developed over the polar high pressure surface. It is an upper air phenomena which after extending moves deeper inside the continental areas of North America and Russia. right? And they are particularly developed and strong during winter season. So already severe winter is complemented or in fact affected more by colder winds. Got it? So that's what we call it, polar vortex. So any question if you have? Huh? Vortex? Just like cyclones. Once they are broken, they'll cover till the ground. Once they are away from the polar areas, they'll cover the ground also. They are broken in the form of cells and they'll travel. They'll gradually cover till the ground. Western coast of? Sorry? Yes. So that's a different oscillation. That's a seasonal oscillation, that's a regular one. And this North Atlantic Ocean oscillation is exceptional. It's not a normal phenomenon. That Bermuda High coming into Azores High and Azores becoming Bermuda High, this is a seasonal one. This will be a regular phenomenon. The North Atlantic oscillation is associated with the difference in the value of pressure between Azores High and Icelandic Low. Right? That pressure variation is not normal throughout the years, every year. So once in a blue moon or maybe on 2, 3, 4 years, there will be positive and sometimes there will be negative. For example, monsoon. So rainfall produced from monsoon is normally normal, but sometimes it will be exceptionally high, sometimes it will be exceptionally low. Right? That's a matter of concern. Normal is not concern. Whatever average is there, that's not concern because you are used to it. But whenever there is deviation, up to the extent that it can affect the humans and its activities, that becomes a matter of concern. So North Atlantic Ocean oscillation is such exceptional oscillation across the years between the pressure belts of cells in the high pressure cells and low pressure cells in the Atlantic Ocean. Temperature will be affected when the rainfall is very high or higher. Especially that's a winter phenomenon in that area. Right, November to April. So in that period when the temperature, rainfall is more, temperature will dip down. And rainfall very often in that area will take place in snowfall. No, first you get clear about the movement of pressure cells is different phenomena. The North Atlantic oscillation is different phenomena. Right? Movement of pressure cells are in response to the seasonal variation in temperature. And that is a regular phenomena. When during winter season, the high pressure cells will be located close to the continent. During summer season, it will move away from the continent. And that's a regular phenomenon. When we talk about North Atlantic oscillation, we basically have a comparative analysis between the high pressure cells and the low pressure cells. The difference in them, let's say difference is, a normal difference is 100 millibars, right? Maybe sometimes 99, 98, 104, 103 doesn't make much difference. But that 100 may be 115 or maybe 85. So that is oscillation. And nobody knows that why it happens basically. just like an El Nino phenomena, but the impact of El Nino is much more severe as compared to the North Atlantic oscillation and much wider. El Nino is supposed to have its impact all over the globe, whereas North Atlantic oscillation is confined to the West European areas. That's how we are indirectly learning about temperatures also. Exceptional case of temperature, because these are basically a byproduct of temperature variation only, right, on the ground. For example, once we finish oceanography and we discuss the role of Gulf Stream, North Atlantic drift, the Canary Current, the variation in the Canary Current on the coastal climate, then you will learn that also, and then you can correlate further. When we discuss atmospheric circulation, we'll talk again about temperature, how north-south variation, why the insolation varies, and the net effect of insolation is more in the 40 degree north to 40 degree south, less in 40 degree to 90 degree. And that what we call north-south energy balance, and that creates atmospheric circulation. So this is basically, that's why every area of climate is somehow affected by temperature only.
Temperature is itself product of rainfall or winds.
No, temperature is a product of multiple factors. We have already listed around 7-8 factors. And apart from insolation, almost all the factors are dynamic. Right. For example, the continent land-water contrast. It's not dynamic as far as the land-water is concerned, but what is happening on the land will affect the land-water contrast. Let's say more amount of pollution, more amount of deforestation, more anthropogenic activities in terms of various like crackers and other things. So will affect the land-water contrast in its extremes. So here man becomes more central to the environmental conditions. जब हम लोग man-environment relationship पढ़ेंगे, that is in perspective in geography and geographical thought, all these you can cite as an example without going into the books. Right? If you remember and recall these things, you can bring those informations which will make your answers non-bookish. And you'll always get more marks in human geography as well. Right? Like for example, system analysis, quantitative revolution, or maybe environmental determinism, possibilism. Let's say there may be a question that environmental determinism has rebirth after the basic concept of global warming elaborate. So nowadays we have started respecting more to the environment as compared to, let's say, 50 years back. So we have started respecting man's environment has forced us something to respect it again. So that is rebirth of a reincarnation of environmentalism philosophy in the modern era, post-modern era. So you'll have to use all these examples. The North Atlantic Ocean oscillation, the El Nino phenomena, the monsoon, the frequency and intensity of cyclones, both temperate and tropical, all these are examples of excessive interference of humans with respect to nature. So that again, environmental determinism. Winds. First, the factors affecting wind motion. The most important factor would be pressure, gradient, force. I hope we understand it. If not, I'll explain it. Any one of you who does not understand it? Pressure, gradient, force. A force generated because of the gradient or the slope created between the high pressure and low pressure. That is the fundamental factor behind air motion. Right? The direction of PGF is always perpendicular to the isobars. Right? If allowed, independently, the direction of wind will also be perpendicular to the isobars. What are isobars? Huh? या खुदा, पूरा प्रेशर सिस्टम हम लोग खत्म कर चुके हैं।
Actually, ये word अभी आया है।
मैंने बार बार बोला है एनसीईआरटी पढ़ा करो। If allowed, like if the pressure gradient force is the only factor affecting wind, no other factor is interfering. Isobars are isotherms, just like isotherms. Isotherms. Temperature, the line joining places having equal temperature, line joining places having equal pressure is isobars. Now here I'll try to explain it. हो सकता है वो भी आप लोगों को शायद पता नहीं हो कि spacing between isotherms and isobars is indicative of steepness of the gradient. If the isotherms and isobars are closely spaced, steep pressure gradient is steep temperature gradient. If it is widely spaced, gentle pressure gradient, gentle, just like contours, right? So contours are line joining places having equal height. So the water flow along a slope will be directly proportional to the steepness of slope. Similarly, in temperature gradient, heat flow will be directly proportional to Tg. And in the case of pressure gradient, wind velocity will be directly proportional to Pgf. Right? So here, the Pgf affects the wind velocity, which is directly proportional to Pgf. It also affects the volume of the wind reaching in a particular area because of catchment area we have already talked about, right? So if we see, there are two types of isobars, elongated or roughly linear. It will never be a straight line, right? But if we imagination it is linear isobars, roughly linear across the globe, slightly zigzag, that's a different issue, will correspond to isotherms only. So the let's say suppose it is a high value isobars, this is a low value isobars, the direction of the pressure gradient will be like this. And pressure gradient will always want the wind to move perpendicular to the isobars. Similarly, the isobars may be circular also, right? So everywhere in a circular isobars, the direction would be towards the center, perpendicular to the isobars. Wherever you draw it, it will always be towards the center or perpendicular to the isobars. Even in the circular, the primary difference is that the isobars in a linear, the pressure gradient force along a linear isobars are unidirectional. Pressure gradient force along a linear isobars is unidirectional, whereas along a circular isobars it is multidirectional. It will help you learn the difference between geostrophic wind and gradient wind, right? So along a circular isobars it is multidirectional, and along a linear isobars it is unidirectional. Hopefully we can understand. For example, let's say suppose subtropical high pressure belt is expected to roughly be linear, and equatorial low pressure belt, even if it is circular and the circle is very big, for localized region it will be straight line, just like the earth circle. Like for example, earth, we know that it is spherical in shape, yet we don't feel because the circumference of the circle is very, very big. So for good local area, that will be linear. So I'm talking about the circular isobars which are much bigger, like Azores High, may appear a localized, but it's a big one, huge one. So even that will not be circular isobars in terms of the PGF. That will be linear locally. Hope we are getting it. The second most important force is Coriolis force. Produced because of rotation of the earth. Identified and invented by Ferrel. That's why we say, as per Ferrel's law, fluid, that is wind as well as ocean currents, will be deflected rightward in the northern hemisphere, leftward in the southern hemisphere, because of angular momentum produced because of rotation of the earth. Ferrel's law. As per Ferrel's law, any moving fluid, if it is static, it will not. Any moving fluid will be deflected rightward in the northern hemisphere and leftward in the southern hemisphere, and the value of Coriolis force is determined by multiplication of theta. Sin theta, sin 0 is 0, sin 90 is 1. थोड़ा सा मैथमेटिक्स में पढ़ा देते हैं तुम लोगों को, इंजीनियर्स को शायद याद होगा, right? If you multiply anything to 0, it will be 0, and theta is the angle of the latitude. That's why from 0 to 90-degree latitude, the magnitude of Coriolis force increases. That means deflection increases. For any circular motion, Coriolis force must be there. Hopefully we understand. Because pressure gradient force is the primary force, remember it. So if we talk about pressure gradient force, the wind will always have linear motion. Right? To have it a curved path, there must be some deflection. And the deflection is produced by Coriolis force. So that Coriolis force will, if the Coriolis force is very high, it might produce circular motion. And circular motion is indispensable for any cyclonic motion, any vortices. That's why polar areas have vortices, equatorial area doesn't have. Or subtropical area doesn't have. Subtropical areas also converges in the upper air, there is convergence, but even that is not having that, right? So deflection, and because of Coriolis force, the general direction of wind in the northern hemisphere is clockwise, and in the southern hemisphere it is anti-clockwise. How? We can easily understand. That will be exactly opposite in the case of anticyclone. General direction of wind turning rightward in the northern hemisphere, turning leftward in the southern hemisphere. Anti-clockwise, clockwise circulation. So Coriolis force, the magnitude of Coriolis force is determined by the latitude and the speed of the moving fluid. Coriolis force is directly proportional to both. Now this is not directly proportional of mathematics कि दोनों return नहीं कर सकते हैं इसमें.
Sir, where it is using the word fluid in place of wind?
When we use fluid, both, then we include ocean currents as well. So that's Coriolis force is common to both. Now, the direction of Coriolis force is perpendicular to the wind direction. The magnitude of Coriolis force is directly proportional to PGF. Because PGF is directly proportional to wind velocity. I mean, other way around, wind velocity is directly proportional to PGF and Coriolis force is directly proportional to wind velocity. So Coriolis force in that case is directly proportional to pressure gradient force. Higher the pressure gradient force, greater the Coriolis force. Right? But if you look at the direction of force, right, it tries to negate PGF. And occasionally is exactly opposite to the PGF, especially when their magnitude is equal. You didn't get that? Even I didn't get that. Let's try to get it. Look at here, high pressure area and low pressure area. What will be the direction of pressure gradient force? Exactly this way, right? Initially, when the wind starts moving away from the high pressure cells, its speed is relatively very slow, very gentle. But once it moves towards the center of the low pressure, its speed increases, right? So the Coriolis force will also increase. And if the wind is moving towards higher latitude, that will be further increased, higher latitude. Now, if let's say, suppose exactly the wind speed is this, so sorry, direction is this. So if the wind direction is this, at this particular point, the direction of pressure gradient force will be this, if it is a linear isobar. So this is the direction of one component. What will be the direction of other component? Engineers. 90 degree to this, right? This will be the direction of Coriolis force. When it has moved, let's say further, the direction of pressure gradient force will all be again here, and the direction of Coriolis force will be perpendicular to this. When it has moved further, the direction of pressure gradient force will be this, and direction of Coriolis force will be this. ज़्यादा हो गया? है ना? ज़्यादा हो गया?
नहीं सर, ये छोड़ रहा है।
ज़्यादा हुआ? ओके। अब एक बच्चे की तरह लेते हैं हम लोग, हैं? छोटे बच्चे की तरह. This is the direction of the PGF, right? So if PGF alone is allowed to dictate the direction of the wind or displace the wind, then wind is supposed to move always away from the origin point, always away from the origin point. This is the origin point. So wind is always supposed to move away from the origin point. Let's see Coriolis force. If Coriolis force alone is allowed to dictate terms and conditions with respect to wind, forget about PGF. Now, the Coriolis force want turn rightward, turn rightward, turn rightward, keep on turning rightward, come back to its original position. So what is the ultimate aim of Coriolis force? To bring the air back to its original point. And what is the ultimate aim of PGF? To take the wind, air always away from origin point. I have started moving from here, let's say. A force always want me to go away, and some force is pulling me to come down, come near. Isn't it exactly opposite? The direction of the two forces ultimately, maybe in the tug of war, the force is much stronger, so it will keep on dragging me towards its direction. But the another force is, especially if you see the direction, ultimately they are exactly opposite to each other. Right? Now, when these two forces are exactly balanced, one is pulling me this side, one is pulling me this side, back, what will be the direction of the wind? When Coriolis force is equal to pressure gradient force in terms of its magnitude, the direction of wind will be parallel to the isobars. नहीं समझ में आया? If at a situation where both PGF and Coriolis force is exactly opposite, look at the direction of the wind, which is parallel to the isobars. Got it? Such winds are called geostrophic wind. Clear है? Third factor is frictional force. Frictional force is produced because of the undulations over the Earth's surface. It acts as a brake for the wind and affects the velocity adversely. Frictional force is higher over the continents. However, it's not altogether absent over the oceans. The average height up to which frictional force is experienced is 700 meters. That's the average height of the continent. Right? For example, if the wind is moving over any zigzag, it may be an ocean wave, which will be relatively smaller nature, but if it is moving over a mountain, so obviously it has to pile up, right? And this creates vertical flow as well, right? So that's how frictional force retards the wind velocity. Frictional force is an important aspect in generating vertical flow of the wind, as vertical flow of air, as it causes piling up of the same. And creates what we call tall. That is ridges.
Frictional force is against the average height.
700 meters is 700 meters. Now let's try to understand its relationship. Frictional force presence will reduce the Coriolis force, right? Higher the frictional force, lesser the Coriolis force. So Coriolis force will be inversely proportional to frictional force. Why? Because frictional force reduces the velocity and Coriolis force is directly proportional to velocity. That means presence of Coriolis force will ensure that, presence of frictional force will ensure that Coriolis force does not attain its maxima.
That's why doesn't completes a whole circle.
No. The wind will not complete the whole circle because pressure gradient force is the primary force. Right. So pressure gradient force is the primary determinant of direction. Coriolis force can never exceed pressure gradient force, cannot defy pressure gradient force. Right. So that's why wind cannot come in this direction, cannot come back.
If we compare the relationship between PGF and Coriolis, PGF will be always dominant over Coriolis.
Always dominate. At the most, Coriolis force can be equal to pressure gradient force. It can never exceed pressure gradient force. And for the Coriolis force to be equal to pressure gradient force, it must attain its maxima. That is, all the conditions must be favorable for Coriolis force to attain its maxima and reach equal to pressure gradient force. In the presence of frictional force, Coriolis force cannot attain its maxima, right? Since it cannot attain its maxima, it can't match up PGF. That means in the presence of Coriolis frictional force, geostrophic wind cannot be produced. Any doubt? Hence, geostrophic wind is an upper air phenomenon. Fourth factor is centripetal force. That is force inward, force towards the low pressure center. Especially along circular isobars. This produces what we call gradient wind. The wind which blow parallel to the circular isobars with a constant speed. When PGF, CF, FF and centripetal force all balances together. With a constant speed, सर्कुलर आइसोबार्स में कांस्टेंट स्पीड से चलती है, उसको हम ग्रेडियंट विंड कहते हैं. The example of geostrophic wind is jet stream. The example of gradient wind is cyclone. Example of gradient wind is anticyclone. Now what happens here, if you see along a circular isobar, now once the air starts moving towards the center, the speed will increase, right? So PGF will increase, Coriolis force will also increase. Now if the wind has entered into it, and after if it has intensified in terms of Coriolis force. Now look at here, here also the direction of pressure gradient force will be this only. Here the direction of the pressure gradient force will be this only. Now with the increasing intensity, the Coriolis force might increase, especially along a circular isobars with very low intense, very high, very intense low pressure area. So what will happen? The Coriolis force may defy it and get out of the isobar. But that will be defiance of PGF. And Coriolis force really becomes so strong in a very localized, intense low pressure area that it can defy. But along a circular isobars, here it is also the centrifugal force also, right, which will be helping Coriolis force, right. So what will happen? Coriolis force will want it to go this side. The pressure gradient force will want again drag it back towards the center. So there will be again a tug of war. Here the frictional force will be helping pressure gradient force. Frictional force will be helping pressure gradient force. Centrifugal force will be helping Coriolis force. And then centripetal force will be helping again pressure gradient force, and that's how all will have to be balanced. Only then it will move along parallel to the circular isobars, like this motion. Such winds are called gradient wind. Priyanka कुछ ज़्यादा समझ गई तुम क्या? There are two Priyankas. Let me introduce you to each other. She is also Priyanka. You have introduced yourself. Guys, I hope, can I tell you about you? She is a national level boxing player and a coach of Boxing Haryana. So, प्यार से ही बातचीत करना, ठीक है? So, this is what we call gradient wind, right? And the factors affecting and how they are creating a special situation on the ground and in the upper air. Wind, types of wind. On the basis of speed, we have breeze, very slow, wind, normal, and stream, very fast, jet stream. Valley breeze, sea breeze and land breeze. So with the increasing speed, wind is classified into breeze, wind and a stream. On the basis of temperature, it may be warm wind and cold wind. Right, on the basis of its origin, destination and other characteristics, the main variation is three types. Primary wind, it's also called permanent wind, it's also called planetary wind. Second is secondary wind and is also called periodic wind. Tertiary wind, it's also called local wind. Some of the periodic wind are also local wind. Permanent wind or primary wind, whatever. Primary wind, why it is called primary wind? Why it is called permanent wind? Because of its direction only. That's the only thing which is permanent is direction. Nothing else is permanent, we have already seen. Their zone of origin, their destination can change temporally. So there is a spatial and temporal variation in their location. So permanency, as far as concerned, only direction. Primary, why it is called primary? Basically because they are associated with 7 primary pressure belts. Why they are called permanent? Why they are called planetary? Basically because they cover the whole planet together. When we discuss atmospheric circulation, this will also be a part of surface circulation and upper air circulation. Surface circulation will be primary circulation, secondary circulation and tertiary circulation. If we add this to upper air circulation, our atmospheric circulation discussion will be completed. So when we are going to discuss atmospheric circulation, we'll just give a hint, we'll not repeat it. Remember it. Now, among these primary pressure belts, the origin zone will always be a high pressure area and the destination will always be a low pressure area, right? Now, we have 3 types of primary or permanent winds. All of you have heard: trade wind, westerlies, polar easterlies. Trade wind has its counterpart that's called anti-trade. That is upper air, ground. That's also a wind, anti-trade wind. Let's take example of equator, right? We have equatorial low pressure belt, ITCZ, roughly around. Then we'll have roughly around subtropical high pressure belt, subtropical high pressure belt, that is the idealized one. Then we have subpolar low, then we have polar high. So what will be the direction of the trade wind? Almost straight. Almost straight in both the hemisphere. Surface wind. That's why this is ITCZ or intertropical convergence zone. Direction is from northeast to southwest, southeast to northwest. Right? So northeast to southwest and southeast to northwest. So that's why we pick up northeast trade or southeast trade. Any question? So again, rightward turning, leftward turning, but deflection will not be very prominent because the wind is moving towards lower latitude, towards 0 degree or towards 0 magnitude Coriolis force. So if we want to explain trade wind, they are the wind which move from subtropical high pressure area towards equatorial low pressure belt. The deflection is minimum. the deflection is minimum because we can explain it is moving towards low latitude, that is 0 degree. Northeast trade explain, southeast trade explain, right? The convergence zone, they make a convergence zone which is called intertropical convergence zone. That's why I say it is a more appropriate term than equatorial low pressure belt. Because when we say equatorial low pressure belt, it is geographically fixed. When we say intratropical convergence zone, it may oscillate. It may move northward and southward depending upon the temperature condition. Now explain the characteristics of intertropical convergence zone. Here air rises along the margins itself. Creating a windless or calm central part, popularly called doldrums. Early sailors have put it a name because they used to get stuck in that region the moment they used to reach there. They used to get stuck. Their ship cannot move at all because wind is not there. So they may not be able to use that wind for sailings. Doldrum. That's what the proverb also, caught in doldrums. Caught in a fix. However, the recent observation suggests the presence of wind in that belt moving from west to east. It is called equatorial westerlies. Plays a significant role not only in transfer of energy but also affect the weather phenomena along the equatorial belt. The most developed equatorial westerlies is seen in the Atlantic Ocean. It owes its origin to the convergence tall region, that is pile up, either because of the presence of the continents or it may be because of high waves. Since the continents produces greater effect, it is well developed in Atlantic Ocean and move away from Brazilian coast towards equatorial Africa. Right, but in converge, look at here in the convergence zone, in the middle part, the area will experience along the marginal area, the rise of air will be there, and because of that, central part will be relatively calm zone. Consequently, what will happen? The air will move in this direction along the equatorial belt. That's what creates counter-equatorial current also. Right? Now the air, the part which is rising, the air which is coming and now it is rising, it is returning also, that is the upper air, and that's what we call anti-trade. So it will move like this. So actual motion will be like this all along. This is called anti-trade. That is upper air counterpart of trade wind. And the direction will be exactly opposite to that of trade wind. That's why they are called anti-trade. Every wind which has left its zone must be compensated by the other wind, or maybe by the same wind has to come back, because there is no new wind which is being created, and it's a closed, in that case it is a closed system. It's not an open system that the wind which has left the surface will go higher up in this space. They have to come back to complete the circulation. That's why cellular motion has been suggested by Hadley. Then we have westerlies. Nothing specific about it. You can just see the NCRT, and that will be more than sufficient as far as the information is concerned about it. Moves from subtropical high pressure belt towards subpolar low pressure belt. Right? The deflection will be much higher, very high, hence westerlies. Okay? Moving from this direction. Variation in southern hemisphere, northern hemisphere. Southern hemisphere very strong, extensive, and permanent, because of, again, the reasons we have already explained, because of the strength of the subtropical high pressure belt. Comparatively, variation in southern hemisphere, northern hemisphere. So variation of westerlies in hemispherical variation I am talking about. So southern hemisphere will be very strong as compared to northern hemisphere. That's why you might read roaring 40s, furious 50s, shrieking 60s are the name of westerlies at 40, 50, 60 degree latitude only. Roaring 40s, furious 50s and shrieking 60s at 40 degree, 50 degree and 60 degree latitude.
So we are saying that the trade winds from both the sides they will rise from the margin zone, and hence calm conditions are created now. Then again, from where this air is blowing, I mean this wind is from west to east.
No, when the situation is like this, for example, if the let's say that this is the marginal part. So equatorial zone, a low pressure belt is not a linear zone. It's a zone, transition zone, right? So whatever elongated zone it has, now imagine the wind which is coming, it will not come in a straight and hit each other and then go like this, right? So it will start rising along the margin itself, right? Now margin along the margin does not necessarily mean that there is not a single wind which is coming in that area. And look at the direction. The direction is this, right? When the direction is this, its rise will be like this, and that's why it will return like this as well. Because if it is moving like this, it will return like this. And here, greater part will return, but some part moves like this. That's why we have presently, we'll discuss that normally the explanation of atmospheric circulation is meridional, along the meridian. What Hadley has suggested is meridian. What Farrell has suggested is along the meridian, that is longitude. But what Walker suggests is along the latitude as well. So this equatorial westerlies had its counterpart cell as well. That's what Walker cells we will discuss.
But you said it should be east to west in place of if two air masses are coming in this way.
It should be east to west. Like ऐसे टकराक ऐसे जाना चाहिए.
No, why it is like west to east?
This basically because the piling up will take place somewhere where, if at all it piles up, it accumulates, it will be in the western side, right? So either it will rise, let's say the best part is here. If you see the South American part, why the equatorial Atlantic Ocean has well developed westerlies. Now look at here, this is coming here, this is coming here. So the piling up will be both the sides. So good part will rise, and whatever part has to move, it cannot move in this direction, rather it will move in this direction. नहीं समझ में आया? मुझे भी नहीं समझ में आया. Let's throw water. तुम भी पानी फेंको, मैं भी फेंकता हूँ इस direction.
There is an obstruction.
हाँ, there is obstacle, that's why. Otherwise it won't. So obstruction may be the ocean waves and maybe water. So the direction of throwing water is this. You also throw this. So what will be the direction of? Counter direction will be in this way. The second thing is that whenever you are moving in that direction is not creating a situation of low pressure. If you see that the marginal part starts rising, right? So whenever pile up is there, for any reason, that will be covered. Your answer also, right? So the doldrum may be in the central part in the initial period, but somehow if the pile up is there, that will cover the surface area. So in that conditions, the high pressure and low pressure direction, pressure gradient force will be redirected in this direction, and that will produce equatorial westerlies, west to east.
Due to piling up.
The piling up is the primary factor. That's why Atlantic is well developed. In Indian Ocean, it is not very well developed. It is get broken. In Pacific Ocean, again, it's not very well developed. Because in the Pacific Ocean, pile up is because of ocean waves. In Indian Ocean, monsoon distorts that its presence. Because monsoon crosses the equator. There is a theory that suggests that monsoon is nothing but extension of equatorial westerlies also. One theory explains monsoon as the extension of equatorial westerlies. Though that has been refuted, that's a different thing. But that is one explanation as well. The strength of subtropical high pressure belt. Southern hemisphere subtropical high pressure belt is stronger. अभी हम बात कर रहे थे ना कि northern hemisphere because of the presence of land. that will be continuity and elongation, and the permanency will be broken, and they will be found in the form of cells. That's not there in the case of southern hemisphere subtropical high pressure belt. Clear? Eh?
So why is the direction of anti-trade wind same as the opposite to?
Because anti-trade wind is basically a response of the surface wind. If you heat up the water, water rises like this, right? It moves like this. So ultimately counter direction will be this only. If wind is coming in this direction, the return will not be in that direction. If you are giving me something and I have to give you back, so the direction should be exactly this, the opposite, but the path will be similar.
But in the case of water, it's the obstruction is perpendicular. But in this case, they are.
No, in this case also it's perpendicular, moving in this direction, perpendicular, cellular motion. So if the cell has to be formed, the path has to be same. The direction has to be opposite. शायद मैं क्वेश्चन नहीं समझ रहा हूँ तुम्हारा यार. पक्का है? जबरदस्ती तो नहीं कर रहा? कौन सा पाथ तुम इमेजिन कर रहे हो? ठीक है. नहीं, ट्रेड विंड ये आई, ये ऊपर गई, अब क्या एक्सपेक्ट कर रहा है डायरेक्शन? इधर, मतलब ऐसे जाकर इधर होना चाहिए. अच्छा, it should not come back. नहीं, तो ये कन्वर्जेंस है ना. That's the problem with monsoon. Monsoon has this problem because monsoon there is no proper convergence, and every problem starts from there. So if something is convergent, let's say suppose हम दोनों टकराते हैं आमने सामने से, resultant क्या होगा? यूं होगा, right? If you collide, resultant will be this. Now the cooling effect and the divergence. So divergence is, if you see the connection between the link, the interconnected, we are taking each and every limb separately, right? But when the air comes, cools down, rises, cools down and moves. So it moves is not independent. That surface, assume that interconnection. High pressure cell on the ground, so high pressure is supplying air, so that high pressure will pull the air above it and that will create a chain. It's a chain, it's interdependent. Though we are discussing it separately that there is a subtropical high pressure belt, air will start from there. The moment air starts from there, on the ground there is a divergence, so there will be subsidence. So the moment subsidence is there, the path where air is supposed to descend is fixed from the ground itself. Once the divergence is there, that means we are fixing that, okay, descend here only. You don't have any option to descend somewhere else, rather descend here only. Because we are creating a low here for you to come down. Now come down, imagine now it is going, let's say some air is rising. So an automatic path is created. For example, if you have created an exhaust right there, so automatically you are forcing the air to move in that direction. If you create a counter exhaust there, again there will be move in that direction. Right? If exhaust is there and something is open there, the air will come, circulate within that. So it is the whole system which is creating a path for itself. So it's not only that the ground surface, it's the whole system will have to see into. So if you look at the subtropical high pressure belt, there will be a direction. If you look at the subpolar, the equatorial low pressure belt, there will be determination of direction in that. So that's how the cellular motion will be created. Polar easterlies, right? If you look at polar easterlies, again polar easterlies is the least studied among all the wind, especially the polar highs. Only recently, because of polar vortices and its effect, the scientists have started covering larger, giving larger importance to it. Otherwise, least studied. But it is believed that the high pressure is there. Obviously, it is believed that they move in east-west direction. Obviously, because of very high, again, Coriolis force along the poles. Right? The direction will be east to west. Everything you can write without much trouble. The only thing is that the convergence zone. The high pressure, subtropical high pressure zone, and the convergence zone, subpolar low pressure zones. There are three boundaries, right? Or equatorial low pressure belt, subtropical repeated, and then subpolar low pressure zones. Right? Three boundaries which are promoting or redirecting the whole circulation, atmospheric circulation. We have discussed about the characteristics of equatorial low pressure belt. Convergence is there, but the convergence is of similar characteristics of air masses. The air masses both are trade winds, and the trade winds are roughly coming from the similar region, tropical region, so they do not have much difference. So nothing to worry about. There's not much problem created here. Unlike this convergence, the subpolar low pressure convergence is different, right? When we say subpolar low pressure belt, here the convergence is that of trade wind and, westerlies and polar easterlies. Remember, trade wind is also called tropical easterlies. So whenever you have a term tropical easterlies, that means trade wind. So now, when the convergence is there, now remember it, there is variation in their physical properties. These converging wind differ a lot. When we say physical properties, we take generally into account temperature and moisture content into it. The two most important determinant of any air mass. Right? So temperature and moisture, the two components, they differ a lot. And in the convergence zone, because of this, they do not mix up freely. Rather, they exchange energy in between them along a narrow transitional boundary. Now, this boundary is called front, and the resultant is a lot of atmospheric disturbances. That means intertropical convergence zone are areas of calm zone, area of convergence of similar characteristics wind, and areas of presence of equatorial westerlies. Right? In the subpolar low pressure zones are areas of frontal formations, are area of lot of atmospheric disturbances because of energy exchange. Right? Whenever the energy exchange takes place, this heat energy is exchanged, so obviously there are a lot of upheavals. And that's what is seen in the form of atmospheric disturbances, especially temperate cyclone. They are frontal in origin. We will discuss that later. Then characteristics of subtropical high pressure belt. Again, a perfect anticyclonic condition. in that relative calm condition. Relative calm condition. Subsidence of air. Dry, clear sky. That's all for today. Thank you and take care.